What's going on, everyone? This is Gaurav and welcome to my learning channel. So continuing our journey to understand the basics of probability, in today's video, we're trying to understand the different types of events. So we'll look at mutually exclusive events and then followed by what are dependent and independent events. We'll try to understand both of these concepts with some examples and the mathematics behind it. So without any further delay, let's get started. All right, so let's get started with mutually exclusive events. Now, two events are called mutually exclusive if they cannot happen at the same time. So let's try to understand this with a simple example. Let's say you have a coin and you start flipping the coin. You can either get a heads or you can get a tails. You cannot get both heads and tails at the same time. So these two events, which is event of getting a heads or event of getting a tails, will be called mutually exclusive. Similarly, for a dice, let's say you start throwing the dice, you can either get a 1 or a 2 and all the way up until like 6. So you cannot get like both 1 and 2 at the same time. So all of these events, which is 1, 2, 3, 4, 5, 6, are mutually exclusive events. It's really important to understand the physical significance of mutually exclusive events and independent and dependent events because we will keep on building the mathematics on top of it. So I hope this is clear. Let's try to understand mutually exclusive event with the help of a Venn diagram. So in this Venn diagram, the rectangle represents your overall event space, and you have two events, which is event A and event B. Now, as you can see that there is no overlap between A and B, meaning they are mutually exclusive. If there was any kind of overlap between A and B, then you cannot say that they are mutually exclusive. So mathematically speaking, probability of A union B, meaning probability of A or B happening, is equal to probability of A plus probability of B. Now you can only go ahead and use this formula if the event A and B are mutually exclusive. Now let's look at independent events. So as we have seen that probability of getting any of the numbers, which is 1 through 6 for a dice, is 1 upon 6. And probability of getting heads or tails in a coin toss is 1 upon 2. Now, if you do these two things together, which means let's say you throw the dice and you toss the coin both at the same time, these probabilities won't change. So this is a classic example of independent events. So the event of getting a heads or tails is not impacting the overall probability of getting 1 through 6 for a dice throw. And that's your classic example of independent events. So just to formalize it, if there are multiple events in the event space, the likelihood of one event, if it does not impact the likelihood of another event, then these two events are called independent events. So in terms of the mathematical formula, probability of A intersection B, which is A and B both happening at the same time, will be equal to probability of A multiplied by probability of B. Now, if you're thinking, how did we arrive at this formula? Don't worry about it at this point in time. In the next video, we will try to understand conditional probability. So at this point in time, this formula will become very clear. Let's look at another example of independent event. So let's say you have a box with 9 colored balls. 5 of them are red and 4 of them are blue. So if you draw one ball, then what is the probability that one ball is going to be red? Will be 5 upon 9, and the probability that it will be blue will be 4 upon 9. Now let's say if I ask you to go ahead and draw two balls, but with a width replacement, which means you draw the first ball, you take a look at the color of the ball, you put it back, mix it well, and then draw another ball, and then you take a look at the color of the ball. What is the probability that both of these balls are red? Will be 5 upon 9 multiplied by 5 upon 9. Why? Because during the first time when you're drawing the ball, at that point in time, the overall ratio of red to the total number of balls was 5 upon 9, and it sort of remains the same because you did put the balls back. So this is a classic example of independent events because the first event is not impacting the likelihood of the second event happening. Now let's take a look at an example of a dependent event. So let's say we continue the same experiment. Now the only difference is that you have to draw two balls but without any replacement. So you draw the first ball, you take a look at the color of the ball, you don't put it back, and then you draw another ball and you take a look at the color. So can we go ahead and say the probability of both the balls being red is 5 upon 9 multiplied by 5 upon 9? We cannot say that because now these two events are dependent on each other. Why is it dependent? So probability that it was red for the first draw is 5 upon 9 as we have seen. But the probability that it is going to be red is not 5 upon 9 again for the second draw because your event space has changed because you have already now withdrawn one ball. So you are one ball less. So overall number of balls in that box is just 8 now. And that's why you cannot go ahead and multiply probability of A, probability of B together to come to a probability of A intersection B. So this is a classic example of a dependent events. So I hope this gives you a good understanding of what are independent events, what are dependent events, what are mutually exclusive events. And we will keep on building on top of it with the different mathematical formulas in the subsequent video. Thank you so much and have a happy learning.